Truth. Yes. I'm going to tell Miss Finnan you remember that. She'll be so happy. All right. I'm going to start. 1/2 plus a third. 1/2 plus a third. You have to have a common denominator, which is 6. So 2 goes into 6 how many times? 3 times 1 is 3. 3 goes into 6 how many times? Times 1. So what did I really do here to get the after I got the common denominator? Right? You cross multiply. And we're going to do that today. So once we get the common denominator, we're going to cross. Okay? So this gives us 5/6. The square root of 2 times the square root of 2. It is 2. So if I'm multiplying together two binomials, let me just start. It is not x squared plus 20. Because what's missing? The 9x, right? The 4x plus the 5x. So when I multiply this, Alyssa, my friend, x times x is going to give me x squared. The square root of 2 times the square root of 2 is going to give me 2. But I need the middle term. So I have 1 square root of 2x plus 1 square root of 2x gives me 2 square root of 2x. So let's do this again. So if I take x times x, I get x squared. The square root of 3 times the square root of 3 gives me 3. But in the middle then, I have 1 square root of 3x plus 1 square root of 3x gives me 2 square root of 3x. Okay? Yes, ma'am. What's the square root of, so what's 2 times 2? And the square root of 4? Okay. So we've already solved polynomial inequalities. So now we're going to do rational inequalities. So the inequality f of x is greater than 0 is true when f of x is positive. When f of x is negative. So on the graph, the only thing that's missing, there's no vertical asymptotes. So draw in your vertical asymptotes. So the question is asking, name all the intervals for which f of x is greater than 0, and then for which intervals f of x is less than 0. So f of x is y's, correct? So where are the y's positive? On this graph, the y's are positive here? Where are the y's positive? The y's are positive up here, right? And the y's are negative down here? So when I'm looking at this graph, I want to start with the positive. So this one is positive, correct? So that's going to be negative infinity to negative 3, is that right? And then what happens at this vertical asymptote? What happens to the function? And becomes negative, right? So at the vertical asymptote, it switched from positive to negative. So from negative 3 to what number? Is it negative 1? Okay, to negative 1. What happens at negative 1? It becomes positive, and it's positive all the way to what number? 2. So I'm going to have negative 1 to 2. And then I hit that vertical asymptote, and what happens? Goes to negative until what number? Is that 4? So from 2 to 4. And then at 4, it hits the x-axis and becomes positive. So from 4 to infinity, it's positive. So here's what happens with rationals. Every time you hit a vertical asymptote, or every time you hit a 0, when you hit the x-axis, you have a sign change from positive to negative. So when we do when I do all of the rationals today, we're going to look at vertical asymptotes and zeros. So in the first example, the first thing, you get your zeros from the top. So the zeros are going to come from the top. X plus 5 equals 0. So my x is negative 5. And the next thing I'm going to look at with the with the 0 is, what's the inequality? Is it open or closed circle? Open. So this one gets open. So the 0 comes from the top. Noah, wake up. This is from the top. So I want the vertical asymptotes, and that's from the bottom. So the bottom is x equals negative 2, and that's the vertical asymptote, because I set this equal to 0. And vertical asymptotes always get an open circle no matter what the inequality says. Okay? So I'm going to put on here, I'm going to have an open circle at negative 5 and an open circle at negative 2. And so now I need to test this, I need to test this, and I need to test this. Yes. You test the x's, those zeros, and the vertical asymptotes. What? So, right, we want the positives. Because the sign is greater, so we want them all to be positive this time. So if I test over here, if I test negative 6, if I put negative 6 in top, I get a negative. If I put negative 6 on bottom, I get a negative. A negative divided by negative is a positive, so I want these. So I get negative infinity to negative 5. Then I'm going to test this interval right here, the middle interval. All right, so if I test negative 3, if I put negative 3 on top, I get a positive. If I put negative 3 on bottom, I get a negative. So positive divided by negative, so that's a no. So I don't want that interval. So I'm going to test over here. So if I choose 0 on top, I get a positive. On bottom, I get a positive. So that makes positive, and that's what I'm looking for. So I want these. Okay. So when do you use a bracket? I know, but when? None of these are closed. What? Why? They are, but why? So the vertical asymptote is always open, and this one doesn't have a line, so it's open. Okay? Yes. Always. Good questions. Anything else? Okay, let's go to number 5 on the back. If what? So this one is less than, so you want your negative intervals instead of your positive. Okay, for number 5, I can't start 5 until I factor it. Jordan, how does it factor? Correct. So, and then how do I factor the bottom? Yes. So, the first thing I want is the zeros or the roots. So the zeros come from where? Top. So x equals 4 and 1. And these are going to get closed circles because of the line. And am I looking for positive or negative answers this time? Negative. So on the bottom is the vertical asymptotes. The vertical asymptotes. So what are the vertical asymptotes this time? So I have -2, but I think somebody else said 0. So we get both of those. So my vertical asymptotes are 0 and -2. And what happens to all vertical asymptotes no matter what the sign is? Open circles. So on the number line, the vertical asymptote always gets the open circle, and the 0 this time gets a closed circle. So I'm going to have 4, 1, -2, and 0. Okay, so down the first aisle here, you guys test this. Test this interval. Okay, down this aisle, the second aisle, you guys test this one right here. What? And this one. Okay, the third aisle, you guys do the baby one. You guys do this one right here. And I'll do the last one. Did you get it? Think you're right? I bet you are. Smart. Oh my gosh. Are you talking to yourself or to her? Yeah, yeah. Okay, first row. Is this positive or negative? Did all of you get positive? Yep, I got positive too. What did you get second? Positive, so do I include that? No. How about the baby one? What? The baby one, wait. -2 to 0 was negative. What is, one of you got negative? No, it's negative. Look, watch. If I put -1 in here, what happens in the first parenthesis? Negative. Second parenthesis, negative. Bottom, negative. Here, positive. So you get positive divided by negative is negative every time. -1 minus 4 is negative every day. Yeah. Uh-huh. All right. So the baby one, is this positive or negative? It's positive. What did you guys get? Negative here? Oh, wait, you're right. And then the last one is positive and it's not included. So we had -2 to 0. Make sure the closed circles get brackets, right? And the open circles get parentheses. I think it's a 1, sorry. It is a 1. What? Open circles get parentheses. Unless it's a vertical asymptote, it's an open circle. Okay. Yeah, I'm going to do 2 more. So listen, nothing is going to change, but I'm going to show you how to get some common denominator, and this is where y'all start whining. So just know right now, you're going to write some, but it's not hard. So first of all, look at all of these are set equal to what? Is this set equal to 0? All right. So I have to move this to this side of the inequality, so it's 0 over here. Okay? So I'm going to write 9 over x minus 4 minus 8 over x minus 3. It's less than or equal to 0. So when we started with the 1/2 and the 1/3, when I got a common denominator, what did we do? What did I do with the numerators? I crossed them, right? So I'm going to take 9 times x minus 3, and I'm going to take the minus 8 times x minus 4. Now nothing else is going to change, but I'm going to multiply on top and combine like terms. Okay? So I'm going to have 9x minus 27 minus 8x plus 32. That's just the top. I just multiplied. So I'm going to combine like terms. So I'm going to get 9x minus 8x is x, and minus 27 plus 32 is 5 plus 5. So the denominator didn't change, and it's less than or equal to 0. So now from here, what are my zeros? X is -5, and does that 0 get an open or a closed circle? Closed. And what are my vertical asymptotes? So 4 and 3. And are those open or closed circles? Open. So 4 and 3 are open circles, and -5 is a closed circle. And then we have to test all the intervals. Okay? So does everybody see how to do that? Okay? Can I skip the testing part? Can you all test? Okay. So I want to just show you one more, okay? I want to show you this one. So first of all, I'm going to subtract the 1 because it's not equal to 0. I'm just going to do this to start with. So now we have to put it over a common denominator, correct? It's not. It's 0. Okay, now we have to do the common denominator. Right? I just took the -1 and we crossed. I put it over a common denominator. Okay? So I'm going to distribute the -1. I distributed the -1. What? Because that's from here, because we crossed, remember? Over here, we took the minus 8 times the x minus 4. So this time I took the minus 1 times the 2x minus 2. So then I get x minus 2x is minus x, and then this is minus 5 over, and on the bottom I have 2 times x minus 2, and this is greater than 0. So what are my 0? Negative 5. If I set this equal to 0 and add the x, it's negative 5 still. And on bottom, what's my vertical asymptote? X is equal to 2. Is there an x here? So that doesn't have any asymptote, just this. Okay? All right, so vertical asymptote gets an open circle. The negative 5 gets an open circle, and then you test your intervals. Is everybody good?